So hi everybody, I'm Steve Schaeber from MACS.
Jerry Lemon, same.
And we're here at TMC, Technology and Maintenance Council.
For the American Trucking Association in New Orleans,
Louisiana.
Louisiana.
And this is their trade show. So today we're walking around visiting MACS member booths, and we're visiting a bunch of the truck manufacturers to learn about what they're doing with air conditioning systems and their new products. Seen a lot of cool stuff so far.
Yeah, the most interesting one was at the Volvo booth, where they're showing a piggyback electric compressor for no idle systems directly into the factory unit.
Is that the one that had the shut-off valves?
Yep, they've got the check valves on them so that no backflow when you switch from engine drive. Yay, Monty.
Yeah. I guess he won something cool.
So it makes it so that when you switch from the engine-driven compressor over to the electric compressor when the engine's off, you get no backflow.
Oh, you know what?
It all goes straight through.
Here they are. Here's the Volvo booth right here. Want to go check it out real quick?
Sure.
All right.
So this is the unique item on this AC system. You'll see there are two check valves. So these are flow control valves, so they're one-way valves. And what happens is when it transitions from the engine-driven compressor,
which is down here,
to the electric compressor, which is down mounted under the cab.
What kind of compressor is that?
That's a Sandon.
Okay.
SD7H15. It's got that large diameter clutch on it, the 180 millimeter clutch, standard. This one is actually a 24 volt system. So that'll be a 24 volt compressor, which is different than most of the other ones we see in North America that are 12 volts.
See if we can look down there and see it. Yep, there she is. That is a big clutch. Man, look at that.
That's the same clutch that we find on a lot of the Mack vehicles when that are using, since Volvo's taken them over.
Well, doesn't Volvo own Mack?
Yeah.
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 All right.
So these check valves are basically in order to allow one-way flow for the high pressure gas going to the refrigerant or going to the condenser. So we'll see this line goes down, hits the rail, goes all the way back to the compressor that's under the cab, the 24 volt DC electric compressor. And that'll flow here when the engine's off. So you'll only get one-way flow. And the reason the check valve is on it so that it doesn't flow back to the engine compressor or vice versa when the flow reverses. Everything else is basically exactly the same. So there's no different systems in order to do that. They've got a large dryer, and you'll see the liquid outlet on the dryer splits in a T, so it feeds both the cabin and the rear, so the sleeper bunk as well. So when you're operating off the electric system, it will also be able to feed both. So we'll get full performance out of the truck, whether it's on electric or whether it's on engine driven.
Okay, so the two valves are on the discharge lines of each compressor.
Correct.
So if you close it off, aren't you trapping refrigerant between the compressor and the valve?
There may be some trap there, but more likely what will happen is when you're doing the suction scavenge, so you'll pull all the gas out of both suction lines until there's basically ambient pressure in the suction line being drawn by the other compressor. And you may get some backflow through that compressor in order to balance. But even if there's only a little bit of gas trapped under pressure, it's not going to be material to the performance of the AC system.
So it'll still work even though there's a little bit of gas trapped that's not being used?
You're going to generally have less than an ounce of refrigerant, even though it's under pressure.
Okay.
Because it's not liquid.
Right. Takes up less space.
A lot less space. Right. Even though it's under pressure, it's not going to be a material issue in the amount of refrigerant in the system.
So how unique is this?
Put it this way, I have not seen it on over-the-road trucks other than a system we developed as a demonstrator back in 2016 for a law enforcement vehicle.
Really?
So we did exactly the same thing. We had compressor and two check valves and a set of fans in front of the condenser in order to provide the cooling necessary. So there, first cool new thing I've seen on a truck AC system in a lot of years.
Yeah. All right, well, let's keep moving on. We got some more show to see.
And if we stop here at Tico or Tico, they've got an electric truck on display. And you can see this is the condensing unit and the compressor assembly. They're running SPAL, PWM, brushless motors, and brushless fans. to draw the air through the condenser. And PWM control, you can tell because you've got control power. So you've got power, ground, and then you've got your 2 control circuit wires. And if you can get a look right in under here, on the other side, you may see that there is a compressor in there, a standard electric compressor.
A little bit too dark in there to see it on this camera, but
It's probably high voltage because this is going to be a 700 volt machine.
700 volts.
Yep.
So is that air conditioner, is that also controlling battery for the vehicle, or?
It would be as well. So they've got an integrated battery thermal system, if they're even worrying about it. The reason we have to cool the batteries is when we're doing high charging rates or high discharge rates, it heats up the batteries. But for the application for something like a yard truck, you don't have hard acceleration, you don't have high speed.
Well, it
so
depends
you
on
don't have
who's driving the truck.
Well, and a lot of these are governed to as low as 10 miles an hour for yard speed.
So they're not getting real fast. They're not going real fast.
Getting real fast, and their discharge rates out of the battery are relatively low as a percentage of how much charge capacity is in the batteries. It's probably about 2% per hour.
So they probably need that more for heating the batteries in the wintertime.
Right, and that'll be a heater function. They'll either do it with a glycol-based coolant that they're running through an electric PTC heater, a high voltage heater, or they're just going to blow hot air in that they're scavenging from the cab heater. A lot of these trucks, this one not so much, but a lot of trucks will have an air-to-air or a unit-to-air PTC heater, so there's no coolant that they have to heat. So that'll blow directly into the cab, and then they'll scavenge that air and blow it into the batteries. So this is a battery box assembly. And they're going to have probably 120 to 150 kilowatts of battery storage on each side. So what else do we want to look at?
Why don't we check out this electric Freightliner here?
All right, so we've got a Freightliner
E-Cascadia.
current model. And this is the front end where all the AC work goes. So basically it's a standard front end AC package. All the hoses, dryer everybody will recognize, condenser everybody will recognize. The big difference is when we get down here. That's your condenser up front. And then when we get down into this part, that's our distribution block. And it'll actually feed from there to a chiller unit that chills the glycol-based coolant that goes to cool the battery packs.
So this has coolant and refrigerant in it?
Yes.
Okay.
So that'll be a stacked, what they call a brazed plate, stacked chiller unit. And then down, if you get down underneath, you'll see the actual AC compressor or the electric compressor unit. Once again, it's going to be a high voltage system. So it'll be running at 700 volts, plus or minus. So if you look right there on the bottom plate, that long cylindrical aluminum thing that's bolted down, that's your compressor. So that will provide anywhere between 8 and 11 kilowatts of cooling capacity, depending on how they have it set up and which one they've got.
It looks like is that a brazed plate heat exchanger under there?
Exactly. So there's the brazed plate heat exchanger. It's actually a pretty big unit for the application.
So is one of them doing thermal management for the battery and another one doing cabin?
There's only one brazed plate heat exchanger. That's the lower one.
Okay.
And that will do, all that'll do is that'll be cooling the coolant loop for the batteries. So that'll be doing the battery cooling system.
Okay.
At the same time, there's going to be a electric PTC high voltage heater heating the coolant for when they need to warm the batteries. So on cold days, you want to precondition the batteries so they're warmer, so they take a charge better and they operate better. So from the driver's point of view, this is basically a glass cockpit. So all of there's no analog gauges or anything like that. Everything is digital. All the controls are digital. You have analog climate control systems and the standard red and yellow brake line systems for air brakes. So other than that, everything's the same. Really nicely laid out package. It looks like everything is nicely accessible in here. The operator, the driver, will not really see any difference between the current model Cascadia and the e-Cascadia as far as his operability goes. If you're ever servicing these trucks, one thing to be really cognizant of and careful of, all these orange cables, those are high voltage cables. So anytime you see orange cables, please don't cut them. That will hurt a lot for a very short period of time. And that's the high voltage system. And once again, always be careful when you're working in here not to disturb any of the high voltage systems.
So that was cool, and that's the kind of stuff that we're seeing here at TMC this year.
Everybody's got their electric trucks. Everybody's got their electric yard trucks. Everybody's got all their electric application stuff, charging units, the whole bit.
Yeah, but there's still a lot of traditional diesel powered engines.
Exactly,
too.
And that's something that's never going to go away. Not in the near future anyway. We're still going to have these diesel trucks. We're still going to have all that application stuff.
This is really cool.
Yeah.
This is like every trainer's dream.
Right. So the guys at Loves have built a training trailer so they can get the technicians trained on all the various systems on the truck, everything from hydraulics, air brakes, electronics, starter systems,
and of course,
HVAC systems,
air conditioning.
Right. So they've got these set up. So they've actually put in some really neat features. So they've got glass tubes so that they can see the condition of the refrigerant. People can understand what's going on, everything like that. They've got readouts, they've got gauges, they've got an accumulator showing how they work and where the pickups are and everything else.
And an orifice tube.
And an orifice tube. They show the cutaway compressor. Now that's not the compressor that's being run in the back. That would be a standard compressor we would see. This is the 10 PA 17 or 15C type with a 10-cylinder compressor on it. And they've got the double-ended pistons.
So that's just a picture of compressor.
Because
compressor. In the back, it's really like a compressor out of a refrigerator.
Exactly.
It's operating this, right? All right, cool. Let's keep heading down the road.
Thanks,
yeah,
Justin.
man. Thanks, guys.
All right, so the show's over for today.
Yep.
Over for Steve for the year.
Yeah, I'm out tomorrow. Well, we still have a couple of study groups we have to go to today.
Yep.
We're going to go to S5, has their closing meeting, their business meeting at 6 o'clock tonight. 6 o'clock. And then there's still 2 more mini tech sessions to go to this afternoon.
Right.
So we'll hit those up. We'll do the business meeting and then dinner.
Dinner.
Yep.
Dinner in Nolans.
Yeah. So, hey guys, thanks for hanging out with us on our little tour of TMC. If you have any questions or any comments, please post them
to us.
Please post them below. And if you like our videos, please give a thumbs up and please subscribe.
And if you don't, tough.
Yeah. And also, please subscribe to get notified of future episodes. I'm Steve Schaeber.
And Jerry Lemon.
And we'll see you next time.
Bye for now.